Basically, about 2 billion years ago, a free-living bacterium got swallowed by a larger cell. The two of them came to an arrangement. The arrangement they came to with our cells is the deepest contract in human biology. We call them mitochondria. You can't really fix the productivity of the factory by improving the speed of the workers alone if half of the workstations are empty. You also have to hire. Hello, everyone. Welcome to Biohacking Beauty, the podcast that links longevity science and skin health. Today, I am on my own. Anastasia is not feeling great, and this episode needed to come out on time. So, unfortunately, this is a throwback to a few years ago before we could get Anastasia on the podcast. So, you got me today. My name is Amitay Eshel, co-founder of Young Goose Skincare, the world's leading longevity skincare company. We actually prefer skin optimization lab. But anyway, today we have a really cool episode. It is an episode about the most important roommates in history. Yep, we are going to talk about something special. Basically, about 2 billion years ago, a free-living bacterium got swallowed by a larger cell. The larger cell did not digest it. The bacterium did not die. Instead, by accident or by selection or by both, the two of them came to an arrangement. Bacterium kept doing what bacteria do, which is convert sugar and oxygen into chemical energy. The larger cell kept the bacterium alive in a temperature-controlled, nutrient-rich environment with no predators. That arrangement is the reason you and I exist. Every cell in your body that needs more than a trickle of energy still hosts the descendants of that ancient bacterium. We call them mitochondria. They have their own DNA, distinct from the DNA in the nucleus of our cells. They have their own membranes. They divide on their own schedule. They are, in every meaningful biological sense, still microbes living inside us or alongside us. The arrangement they came to with our cells is the deepest contract in human biology. Yes, if you think your landlord has like a, deep contract, think again. 2 billion years old, renewed in every fertilized embryo, negotiated continuously in every working tissue, and in your face, in every cell of your skin. The contract is now slowly, predictably, measurably fraying. Actually, not in one way, in two. The fact that there are two halves to this story and that the second half has been quietly understood in the cell biology literature for over a decade, but almost never addressed in cosmetics, is the reason we built the product we are going to talk about today, or this is the reason we felt it's important. I'm going to tell you the two halves of the story, but we're going to do it one at a time. Then I'm going to tell you in the middle how we even know any of this. And then I'm going to tell you what to do about it. So let's get it going. Skin is one of the most mitochondria-dense tissue in your body. Yeah, mitochondria is not dispersed evenly. First of all, I think it's probably important to know mitochondria. When we say mitochondria, each cell has many mitochondria in it. And depending on the metabolic demand, so like the energy demand of each part of your body, each organ, you have different concentration of mitochondria in it. Most people, when they think about skin, they think of it as like a flat barrier, a surface, a thing you put cream on. Biologically, that picture is completely wrong. Skin is an organ, and it is the largest organ in your body. It renews itself every 4 to 6 weeks, depending on your age, top to bottom. And it contains things, for example, that are called fibroblast, which build collagen, elastin, hyaluronic acid, what we call the structural scaffolding underneath the surface you see in the mirror. It contains keratinocytes, which manufacture the barrier. It contains melanocytes, which regulate pigment. Every one of those cells is performing chemical work all day, every day, in real time, responding to UV DNA damage, to chemicals they interact with, to even to touch, right? Every one of those cells run on energy. Inside every one of those cells, between 200 and 2,000 mitochondria are running the critic acid cycle and the electron transfer chain and producing the molecule called ATP. ATP is the actual currency of energy in every living thing on Earth. It is the molecule that pays for protein synthesis, as far as the skin is concerned. It is the molecule that pays for DNA repair. And it is the molecule that pays for the lipid rebuild of your barrier after you wash your face before you go to sleep. When you are 25, your skin cells are flush. They have more ATP than they need. They build collagen on demand. They repair barrier disruptions overnight. They handle the daily insults of light and air and water without ever billing the rest of your body for the cost. When you're 60, this is not longer true. The contract has begun to fray. So, the first half of the fraying is the half that the field has known about for about 30 years. The mitochondria you have basically stop running at full output. The technical version of this story involves a cofactor called NAD+. NAD, I'm just going to use NAD from now on. NAD is the small molecule that hundreds of enzymes inside the mitochondrion use to do their jobs. Sirtuins use it. PARP enzymes use it. I call these the police and the fire department of our DNA. The electron transport chain uses NADH, which is NAD with 2 extra electrons attached. And when NAD is plentiful, all of these proteins run at their design speed. When NAD is scarce, they slow down. In 2012, a graduate student in Sydney named Hugo Masudi did something that, looking back, seems obvious. He took skin biopsies from human subjects across the age spectrum, prepared them, and measured the NAD inside. He published the results in the journal PLOS1+1. The result was that between the ages of about 35 and 70, NAD in human skin drops by roughly half. The sample size was 30. The decline tracked with rising oxidative stress markers in the same tissue. The reference is in the show notes that we're going to give you, and maybe we're going to do... maybe the show notes are going to have like PDF that you'll be able to download, and that would be more comprehensive. We'll see if we have time. Again, this needs to come out at a certain time. But hopefully you're going to have a reference PDF that you can download. And you'll be able to pull the study yourself. This is one of the few direct human skin NAD measurements in the published literature. Most of what we know about NAD decline in skin, we still extrapolate from this paper, or we kind of start from that paper in 2012 is kind of the starting point for most of what we think about when we think about NAD in skin. The visible markers that we associate with skin aging, the thinning, the loss of firmness, the slower healing after an assault, the gradual dullness, are downstream of this single fact. The cell is being asked to do the same work with half of the NAD, half of that cofactor. The cell does really what it can at this point. The face, year by year, starts to show it. If this were the only thing happening, the strategy for skincare would be obvious. Replace the cofactor, help the chain run faster, quench the reactive species that the chain leaks when it runs at suboptimal speed. The entire science-led skincare category for the last 15 years has been built on that strategy. Antioxidants, peptides, even NAD precursors, since we've introduced them, are now pretty common, not pretty common, but you start seeing it in the market. Obagi just launched an NAD precursor product. The famed Brian Johnson, launched his own. The reason I hesitate is because, it's very difficult to make one that actually has the NAD precursors intact by the time they get to their skin, but it's a strategy nonetheless. Peptides, we mentioned peptides that signal collagen. So all of those are targeting the function that your cells already are designed to do. For about 20 years, this was the whole story of medical grade skincare. How do we poke the body and tell it, hey, you need to do this? Then someone started counting. I'll get to the counting in a moment, but first, I want to take a step back and tell you how we know any of this in the first place. The story is probably shorter than you think. In 1933, a young German biochemist named Hans Krebs was fired from his job in the University of Freiburg. Krebs was a research physician, Jewish, and the Nazi government had just passed the law for the restoration of the professional civil service, which removed Jewish academics from German universities. Krebs was 33 years old. He had been working, before he was fired, on a problem in the chemistry of energy. He was trying to figure out how cells turn food into power. The Nazis didn't care. He landed in England and he went first to Cambridge, where he was offered a junior position. Then in 1935, he moved to Sheffield. Sheffield was a steel city, like Pittsburgh. Not a famous research university. No offense, Pittsburgh. He was given a small lab, and he had a few graduate students with him. In 1937, he submitted a paper to the journal Nature describing a circular sequence of chemical reactions inside the mitochondrion. The cycle had 8 steps. It took a molecule called acetyl-CoA and squeezed the chemical energy out of it, 1 electron at a time, until what remained was a carbon dioxide and water. It ran in every aerobic cell in our body and on Earth. It was, in essence, the central engine of human metabolism. Nature rejected the paper. Krebs sent it to a smaller journal, and they accepted it. The cycle has been known as the Krebs cycle ever since. End of the Disney movie. Anyway, he won the Nobel Prize for it in 1953. Maybe that's the end of the Disney movie. Well, I tell you this story for 2 reasons. The first is that the biology that is right now in the cream on your bathroom shelf was figured out in a small lab in Sheffield by a refugee with a few graduate students after his career-defining paper was rejected by the most famous journal in the world. The story of how we know what mitochondria do is not a story of pedigree. It's a story of persistence. It's actually a story of epistemological truth. The second reason is that this is an episode about an energy economy that operates over decades. And Hans Krebs' story is a reminder that the most important biological discoveries are the ones that compound. They are slow. They reward patience. The skin on your face works in really the same way. The biology that ages it operates on a 30-year timescale. The biology that protects it has to operate on the same timescale. There's no 24-hour version of this story or of Young Goose products, really, That's something deep I would love our clients to understand eventually, is that we're here for the long run. We're products that need to be used for 10, 20, 30 years. And it breaks my heart every time someone comments, hey, it's been 2 weeks and I haven't seen anything. But now let's go back to the counting. So here's the part of the story that is not yet in most skincare marketing. When you take a skin cell from a young person and a skin cell from an older person, and you do not just measure the function of their mitochondria, but you count the mitochondria themselves, the older cell has fewer. I'm not talking about damaged ones. Fewer, like the number of mitochondria is done. The cell's capacity to replace its mitochondria population, a process called mitochondrial biogenesis, has declined. This is the second half of the contract that is fraying. The first half is that the engines you have run worse. The second is that the cell is building fewer of them. The master regulator of mitochondrial biogenesis has a name that does not really roll off the tongue. It's PGC1 alpha. PGC1 alpha is a protein that turns on the genes that build new mitochondria. When you exercise, especially resistance training and endurance training, PGC1 alpha goes up, and your muscle cells respond by manufacturing new mitochondria. When you're exposed to brief cold, PGC alpha goes up in certain tissues. When you sleep well, when you eat enough proteins, when you keep your blood sugar in range, PGC alpha is supported. When you're chronically stressed, undernourished, or eating the, crappy food, sleep deprived, or really sedentary, PGC alpha falls. And as you age, even if you do everything right, its response to cues decline. The cell is, in slow motion, losing the ability to staff its own factory. I want to make this concrete because it's the single most important sentence in this episode. If you imagine each one of your skin cells as a small factory and each mitochondrion inside as its working force on its, its proverbial production floor, then aging skin is doing two things at once. The remaining workers are slower, and there are fewer of them on the floor than there used to be. You can't really fix the productivity of the factory by improving the speed of the workers alone if half of the workstations are empty. You also have to hire. If you only address the first decline, the function side, you're leaving the second on the table. The vast majority of skincare, even the science-led part, is still entirely in the first column. We don't talk negatively about other companies. We only shout out companies that we really like. But there is a large movement around urolithin A, and a lot of what we talked about now about like exercise and how it improves mitochondrial function. The patents on that molecule are owned by the largest players in health. And because of that, the bandwidth they occupy, the story that they tell is very impressive, and it's very, they have the money to pay Andrew Huberman for a year talking about urolithin A before mentioning a brand of urolithin A. That's a lot of money. And they're only talking about one part of the story. They're only talking about function. And I think it's not fair to a consumer. It's just not fair to basically talk about some of the science. But going back, this insight is the reason the cream we're launching is built the way we built it. So we use 6 hero ingredients. 3 of them address function, the speed of the workers, and 3 of them address count and downstream support, the number of workers on the floor and the cell's ability to keep them running. So let's walk through what each ingredient is doing and why it is in its respective column. The cream is called CARE, Cellular Anti-Aging Repair and Energy. And it might sound familiar because we already have a cream like that. But CARE was the first product we ever launched with. So shout out to those here that have been with us since the beginning. And CARE was basically the culmination of our project around NAD precursors in skincare. And really, if you can think about it, it's like the first, the canary in the coal mine of NAD in skincare. The problem is that, first of all, science evolves, formulation evolves. We understand cellular function at a much deeper level, both as, science and us as a lab. And we are called to improve our kind of basic formulation. So it's not here to replace Youth Daily, which is kind of our hero moisturizer. It is here to tackle mitochondria specifically, which is, we're going to probably talk about it towards the end, but that's a product for people to use in combination with Youth Daily, or for people under 35 to make sure that they arrive to 35, biologically 25. So it's a product that you can apply morning and evening as the last step of your routine. So cleanse, serum, care, and sunblock in the morning. These three, there are three ingredients there that address function. First of all, we have beta-NMN, which is double encapsulated beta-NMN, because NMN breaks down to niacinamide in liquid, even in moisture. If you take if you have NMN supplements and you break a capsule down and you put it on your tongue when it just arrived, and then use the bottle towards the end of the bottle, do the same thing. The taste is going to change significantly. It's going to be more sour. And the reason is because a lot of it has been now broken down into niacinamide. Keep it in the fridge. That's number one. But we have like this double encapsulation technology that we're going to launch some absorption studies around, but also keeps it stable. NMN, to those who are new to the idea, is nicotinamide mononucleotide, is the precursor your skin cells use through their own pathway to make new NAD. The skin expresses the enzymes NAMPT and NMNAT, which convert NMN and other NAD precursors into the cofactor we discussed earlier, which is NAD. Topical NMN in a vehicle that crosses the barrier refills the local pool of NAD, not the systemic pool, the local one in the skin where you applied it. This is the right tool for the right problem, because skin has its own NAD economy and it doesn't benefit much from a circulating supply. So anytime you're exposed to UV radiation, NAD declines dramatically in the skin. And that's one example. It also happens with artificial light. It happens with pollution. It happens with any irritation. Your body just goes after NAD to quench fires. If you remember my police and fire department analogy from before. So enzymes rely on it, 400 to 600 enzymes, depends on the tissue and state, etc. So replenishing that pool is extremely important. And we don't only do it with NMN, we do it with a complex called NAD Apex that has other precursors and supporting ingredients that are able to address that depletion in about 4 different ways. Methylene blue is the second function ingredient. So methylene blue is a molecule with a particular history that I will save for you guys listening to the methylene blue episode, or maybe we're going to do something in the future. At very low concentration, the kind used in cosmetic formulation, it acts as an alternative electron carrier inside the mitochondrial chain. So it's like NAD brought its brother to help him with a job. So when a damaged complex, specifically complex 1 or complex 3 in the mitochondria, causes a bottleneck, methylene blue accepts the electrons from upstream and donates them downstream. It's kind of a workaround. You can think about it like a heart surgery or whatever, you know. There is a really cool paper. It's called Atamna and Colleagues. If it's in a journal called FASEB in 2008 on human skin fibroblast, submicromolar methylene blue extended the cell's replicative lifespan and increased complex 4 activity, which is kind of what we want. That's where energy comes out of. Hopefully, we're going to create this document and you're going to have this in the show notes. CoQ10, also called ubiquinone, is the third function ingredient. So CoQ10 is the obligate electron carrier between complex 1 and complex 2 and complex 3 of the chain. Without it, electrons cannot move through the membrane. Its level in human skin declines with age. In general, in the body, very pronounced in skin. And topical replenishment at levels that are researched has been documented to raise skin CoQ10 levels and reduce oxidative markers. Notes about those 3 ingredients: we use the top end of researched dosage. So we're not using dosages that were never researched, but we're using the most that has been researched. So those 3 address the function of the mitochondria. You have NAD precursors, electron carrier workaround, and electron carrier replacement. 3 other ingredients address count and the downstream support of the mitochondrial population. Copper tripeptide 1, which is also called GHKCU, is probably the sexiest in this column. A 2018 review of the gene expression literature per the famous Picard and Margolina catalogs approximately 4,000 human genes whose expression GHKCU modulates. Within that list are pathways tied to mitochondrial biogenesis, antioxidant defense, and extracellular matrix remodeling. The peptide is doing 2 jobs really in care. It's doing the classic dermal remodeling work that the cosmetic chemistry world has known about for 40 years, and it is doing more quietly the modulation of gene expression in the background that determines whether the cell can build new mitochondria. Ergothioneine is the second one. One of the coolest ingredients, and something cool about ergothioneine, it's actually more bioavailable as far as like what data shows, more bioavailable when you apply it on the skin than you swallow it. So it's more bioavailable through the skin. It's a sulfur-containing amino acid or amino acid analog that the human body cannot synthesize. We get it from food, primarily mushrooms, and cells take it up through a dedicated transporter called OCTN1. So the body has a specific shuttle only for this antioxidant amino acid, which is super prevalent in skin. That's why I explained the bioavailability. So once inside the cell, ergothioneine concentrates inside the mitochondria and acts as a long half-life antioxidant. So most antioxidants are consumed and turned over in a couple hours. Ergothioneine persists for weeks. It protects the mitochondria that already exists from the kind of damage that would otherwise force the cell into a defensive crouch of sort. So you could think of it as like this mitochondria-specific super antioxidants. Like your body designed itself to use it as a mitochondrial antioxidant. And last but not least, liposomal creatine. By the way, very similar kind of bilayer that NMN has. We've designed for creatine. And the reason you need it for creatine is because creatine in liquid actually turns into creatinine. That's why creatine gummies suck, because it's liquid first, right? And a lot of the creatine gets destroyed, and that's why the testing are really not good when you look at the actual amount of creatine that's there. So skin expresses functional creatine kinase. It was established by Lentz and colleagues, Journal of Investigative Dermatology in 2005. The creatine system holds an ATP reserve in the form of phosphocreatine, which the cells can spend in moments of demand without forcing the chain to ramp up. The special liposomal delivery system, the delivery vehicle that we have, is because creatine is really bad. So first of all, it's the stability, but also creatine is like really bad at crossing the skin's lipid barrier on its own. The function of the buffer is to protect the cell's existing energy economy during demand spikes, which in turn protects the count of working mitochondria. So that is 6 ingredients, 3 for the engines you have, 3 for the engines you need to keep building. There's one thing the cream really cannot do, and that is worth stating out loud. Mitochondrial biogenesis at the body level is supported by resistance training, by adequate sleep, by adequate protein intake, by adequate, creatine intake, by brief cold exposure, or also some would argue by heat exposure, by elevation of body temperature, and by avoiding chronic glycemic stress. You can address the function side of the contract with a cream. You can address the count side with a cream and with the way you live. The contract is fraying in 2 places. Your job is to address both. Well, I want to go back to the bargain. 2 billion years ago, a free-living bacterium got swallowed by a larger cell and decided not to die. The arrangement that followed is the reason your face is capable of looking like a face at all. The thing that is happening inside the cells, your facial cells right now, the slow decline in both the function and the count of those ancient microbes is not a flaw in the system. It is the system. The contract was designed to last exactly long enough for you to pass it on to the next generation. Anything past that is, biologically speaking, a bonus. What is new is in 2026, we can do something about the bonus. The science of the 2-engine decline took about 30 years to assemble. The science of how to address both halves with topical actives took the last 15. The cream care is the result of the assembly. Care is not a promise of reversal. We're not in the reversal business. Care is a way to honor the second half of a contract that has been compounding inside your face since before there were faces. If you want the long version of the science, I'll make a sincere effort to prep the doc and the field document and the field notes and put them in the show notes. The protocol on the back of the care product will guide you how to use it. The mechanism is everything we talked about today. Basically, this is a much more longevity-focused product than Youth Daily and Youth Reset, but it's a cream, so it's juxtaposed with Youth Daily. Youth Daily is built on targeting the entire 12 hallmarks of aging. This is targeting one of those hallmark, which science calls the driving hallmark. So this is the main hallmark that drives all the other hallmarks. So it's less expensive. It's $130 instead of $175, which is Youth Daily. And it's meant to focus on that one hallmark that drives the biggest change. It's not going to give you as much change, visible change, in a short amount of time. This is a pure longevity strategy. And this is the Biohacking Beauty Podcast. I'm Amitay Eshel. And I will talk with you, hopefully with Anastasia, next week. Thank you very much.